High-definition television provides a resolution that is substantially higher than that of standard-definition television. HDTV may be transmitted in various formats: 1080p, 1920x1080p, 2,073,600 pixels per frame; 1080i, 1920x1080i, 1,036,800 pixels per field or 2,073,600 pixels per frame. Some countries also use a non-standard CEA resolution, such as 1440x1080i, 777,600 pixels per field or 1,555,200 pixels per frame. 720p, 1280x720p, 921,600 pixels per frame. The letter P here stands for progressive scan, while I indicates interlaced. When transmitted at 2 megapixels per frame, HDTV provides about 5 times as many pixels as SD. History. The term high definition once described a series of television systems originating from August 1936. However, these systems were only high definition when compared to earlier systems that were based on mechanical systems with as few as 30 lines of resolution. The ongoing competition between companies and nations to create true HDTV spanned the entire 20th century, as each new system became more HD than the last. Ironically, in the beginning of the 21st century, this race has continued with 4K, 5K and current 8K systems. The British high-definition TV service started trials in August 1936 and a regular service on the 2nd of November 1936 using both the Baird 240-line sequential scan and the Marconi ME 405-line interlaced systems. The Baird system was discontinued in February 1937. In 1938, France followed with their own 441-line system, variants of which were also used by a number of other countries. The US NTSC 525-line system joined in 1941. In 1949, France introduced an even higher resolution standard at 819 lines, a system that should have been high definition even by today's standards, but was monochrome only, and the technical limitations of the time prevented it from achieving the definition of which it should have been capable. All of these systems used interlacing and a 4:3 aspect ratio except the 240-line system, which was progressive, and the 405-line system, which started as 5:4 and later changed to 4:3. The 240-line system could have doubled its frame rate, but this would have meant that the transmitted signal would have doubled in bandwidth, an unacceptable option as the video baseband bandwidth was required to be not more than 3 MHz. Color broadcasts started at similarly higher resolutions, first with the US NTSC color system in 1953, which was compatible with the earlier monochrome systems and therefore had the same 525 lines of resolution. European standards did not follow until the 1960s, when the PAL and SECAM color systems were added to the monochrome 625-line broadcasts. The Nippon Hosokyōkai began conducting research to unlock the fundamental mechanism of video and sound interactions with the 5 human senses. In 1964, after the Tokyo Olympics, NHK set out to create an HDTV system that ended up scoring much higher in subjective tests than NTSC's previously dubbed HDTV. This new system, NHK Color, created in 1972, included 1125 lines, a 5:3 aspect ratio and 60 Hz refresh rate. The Society of Motion Picture and Television Engineers, headed by Charles Ginsberg, became the testing and study authority for HDTV technology in the international theater. SMPTE would test HDTV systems from different companies from every conceivable perspective, but the problem of combining the different formats plagued the technology for many years. There were 4 major HDTV systems tested by SMPTE in the late 1970s. And in 1979 an SMPTE study group released a study of high-definition television systems, EIA monochrome, 4:3 aspect ratio, 1023 lines, 60 Hz, NHK color, 5:3 aspect ratio, 1125 lines, 60 Hz, NHK monochrome, 4:3 aspect ratio, 2125 lines, NAHZ, BBC color, 8:3 aspect ratio, 1501 lines, NAHZ. Since the formal adoption of digital video broadcasting's widescreen HDTV transmission modes in the early 2000s, the 525-line NTSC systems, as well as the European 625-line PAL and CCAM systems, are now regarded as standard-definition television systems. Analog systems. Early HDTV broadcasting used analog technology, but today it is transmitted digitally and uses video compression. In 1949, France started its transmissions with an 819-line system. The system was monochrome only, and was used only on VHF for the first French TV channel. It was discontinued in 1983. In 1958, the Soviet Union developed Transformator, the first high-resolution television system capable of producing an image composed of 1,125 lines of resolution aimed at providing teleconferencing for military command. It was a research project and the system was never deployed by either the military or consumer broadcasting. In 1979, the Japanese state broadcaster NHK first developed consumer high-definition television with a 5:3 display aspect ratio. The system, known as High Vision or Muse after its multiple sub-Nyquist sampling encoding for encoding the signal, required about twice the bandwidth of the existing NTSC system but provided about 4 times the resolution. Satellite test broadcasts started in 1989, with regular testing starting in 1991 and regular broadcasting of BS9 chains commencing on November 25, 1994, which featured commercial and NHK programming. In 1981, the Muse system was demonstrated for the first time in the United States, using the same 5:3 aspect ratio as the Japanese system. Upon visiting a demonstration of Muse in Washington, U.S. President Ronald Reagan was impressed and officially declared it a matter of national interest to introduce HDTV to the U.S. Several systems were proposed as the new standard for the U.S., including the Japanese Muse system, but all were rejected by the FCC because of their high bandwidth requirements. At this time, the number of television channels was growing rapidly and bandwidth was already a problem. A new standard had to be more efficient, needing less bandwidth for HDTV than the existing NTSC. Demise of analog HD systems. The limited standardization of analog HDTV in the 1990s did not lead to global HDTV adoption, as technical and economic constraints at the time did not permit HDTV to use bandwidths greater than normal television. Early HDTV commercial experiments, such as NHK's Muse, required over 4 times the bandwidth of a standard definition broadcast. In addition, recording and reproducing an HDTV signal was a significant technical challenge in the early years of HDTV. Japan remained the only country with successful public broadcasting of analog HDTV, with 7 broadcasters sharing a single channel. Rise of digital compression. Since 1972, International Telecommunication Union's radio telecommunications sector had been working on creating a global recommendation for analog HDTV. These recommendations, however, did not fit in the broadcasting bands which could reach home users. The standardization of MPEG-1 in 1993 also led to the acceptance of recommendations ITU-RBT 709. In anticipation of these standards, the Digital Video Broadcasting Organization was formed, an alliance of broadcasters, consumer electronics manufacturers and regulatory bodies. The DVB develops and agrees upon specifications which are formally standardized by ETSI. DVB created first the standard for DVB-S digital satellite TV, DVB-C digital cable TV and DVB-T digital terrestrial TV. These broadcasting systems can be used for both SDTV and HDTV. In the US, the Grand Alliance proposed ATSC as the new standard for SDTV and HDTV. Both ATSC and DVB were based on the MPEG-2 standard, although DVB systems may also be used to transmit video using the newer and more efficient H.264, MPEG-4 AVC compression standards. Common for all DVB standards is the use of highly efficient modulation techniques for further reducing bandwidth, and foremost for reducing receiver hardware and antenna requirements. In 1983, the International Telecommunication Union's radio telecommunications sector set up a working party with the aim of setting a single international HDTV standard. One of the thornier issues concerned a suitable frame field refresh rate, the world already having split into two camps, 25/50ths of a Hz and 30/60ths of a Hz, largely due to the differences in mains frequency. The IWP 11/6 Working Party considered many views and throughout the 1980s served to encourage development in a number of video digital processing areas, not least conversion between the two main frame field rates using motion vectors, which led to further developments in other areas. While a comprehensive HDTV standard was not in the end established, agreement on the aspect ratio was achieved. Initially, the existing 5:3 aspect ratio had been the main candidate bit, due to the influence of widescreen cinema. The aspect ratio 16:9 eventually emerged as being a reasonable compromise between 5:3 and the common 1.85 widescreen cinema format. An aspect ratio of 16:9 was duly agreed upon at the first meeting of the IWP 11/6 Working Party at the BBC's Research and Development Establishment in Kingswood, Warren. The resulting ITUR recommendation ITUR-BT 709-2 includes the 16:9 aspect ratio, a specified colorimetry, and the scan modes 1080i and 1080p. The British Freeview HD trials use MBAFF, which contains both progressive and interlaced content in the same encoding. It also includes the alternative 1440x1152 HDMAC scan format. Format was viewed by some at the ITU as an enhanced television format rather than a true HDTV format, and so was not included. Although 7920x1080i and 1280x720p systems for a range of frame and field rates were defined by several USSMPTE standards, inaugural HDTV broadcast. In the United States, HDTV technology was introduced in the United States in the late 1980s and made official in 1993 by the Digital HDTV Grand Alliance, a group of television, electronic equipment, communications companies consisting of AT&T, Bell Labs, General Instrument, Philips, Sarnoff, Thomson, Zenith and the Massachusetts Institute of Technology. Field testing of HDTV at 199 sites in the United States was completed August 14, 1994. The first public HDTV broadcast in the United States occurred on July 23, 1996, when the Raleigh, North Carolina television station WRAL-HD began broadcasting from the existing tower of WRAL-TV southeast of Raleigh, winning a race to be first with the HD model station in Washington, D.C., which began broadcasting July 31, 1996 with the call sign WHDTV. Based out of the facilities of NBC-owned and operated station WRC-TV, the American Advanced Television Systems Committee HDTV system had its public launch on October 29, 1998. During the live coverage of astronaut John Glenn's return mission to space on board the Space Shuttle Discovery, the signal was transmitted coast to coast, and was seen by the public in science centers and other public theaters specially equipped to receive and display the broadcast. European HDTV broadcasts. The first HDTV transmissions in Europe, albeit not direct-to-home, began in 1990, when the Italian broadcast array used the HD Mac and Muse HDTV technologies to broadcast the 1990 FIFA World Cup. The matches were shown in 8 cinemas in Italy and 2 in Spain. The connection with Spain was made via the Olympus satellite link from Rome to Barcelona and then with a fiber optic connection from Barcelona to Madrid. After some HDTV transmissions in Europe, the standard was abandoned in the mid-1990s. The first regular broadcast started on January 1, 2004 when the Belgian company Euro 1080 launched the HD1 channel with the traditional Vienna New Year's concert. Test transmissions had been active since the IBC exhibition in September 2003, but the New Year's Day broadcast marked the official launch of the HD1 channel, and the official start of direct-to-home HDTV in Europe. Euro 1080, a division of the former and now bankrupt Belgian TV services company Elfacom, broadcast HDTV channels to break the pan-European stalemate of no HD broadcasts mean no HDTVs bought means no HD broadcasts, and kickstart HDTV interest in Europe. The HD1 channel was initially free to air and mainly comprised sporting, dramatic, musical and other cultural events broadcast with a multilingual soundtrack on a rolling schedule of 4 or 5 hours per day. These first European HDTV broadcasts used the 1080i format with MPEG-2 compression on a DVB-S signal from SES's Astra 1H satellite. Euro 1080 transmissions later changed to MPEG-4 AVC compression on a DVB-S2 signal in line with subsequent broadcast channels in Europe. Despite delays in some countries, the number of European HD channels and viewers has risen steadily since the first HDTV broadcasts, with SES's annual Satellite Monitor Market Survey for 2010 reporting more than 200 commercial channels broadcasting in HD from Astra satellites. 185 million HD-capable TVs sold in Europe, and 20 million households watching HD satellite broadcasts. In December 2009, the United Kingdom became the first European country to deploy high-definition content using the new DVB-T2 transmission standard, as specified in the Digital TV Group D-Book on digital terrestrial television. The Freeview HD service currently contains 10 HD channels and was rolled out region by region across the UK in accordance with the digital switchover process, finally being completed in October 2012. However, Freeview HD is not the first HDTV service over digital terrestrial television in Europe. Italy's Rai HD channel started broadcasting in 1080i on April 24, 2008 using the DVB-T transmission standard. In October 2008, France deployed 5 high-definition channels using DVB-T transmission standard on digital terrestrial distribution.